You believe you understand what radiation does to the body, but the story of radiation and living tissue is not the cautionary tale you were told. Doctors drape lead shields against it, entire cities have been evacuated because of it, and the international safety standards governing every hospital, every nuclear power plant, every research laboratory on Earth trace back to what happened in a leaking shed in Paris more than a century ago, where I stirred boiling pitchblende with an iron rod and watched my own hands begin to change. The truth is stranger, more beautiful, and more terrifying than most people imagine, because I did not learn about radiation from a textbook. I learned it from burns that appeared without fire, from fatigue that carried no name, from a substance that glowed blue in the darkness, and slowly, patiently, rearranged everything I understood about matter itself. You think of radiation as a poison, and I need to show you what it actually is. Certain substances have always been dangerous to handle. Acids burn on contact, lead accumulates in the bones, and arsenic disrupts the chemistry of the cell. These hazards follow a logic the human mind finds comfortable, where a substance enters the body, interferes through some chemical interaction, and the body suffers accordingly. When Pierre and I began our work at the University of Paris with substances I would come to call radioactive, a word I coined myself because no term yet existed for what we had found, we assumed something similar had to be happening. We assumed the rules of chemistry would hold, and that assumption turned out to be a serious error. Radiation does not behave like chemistry. It does not need to touch you the way an acid does, or be swallowed the way arsenic must be. It reaches across empty space, passes through barriers that would stop any chemical agent, and alters the architecture of your cells without leaving any trace of entry. There is no wound and no mark of contact, just the quiet, invisible rearrangement of structures too small to see. By the time the body reveals what has happened, weeks or months have already passed, which means the damage and its cause are separated by time in a way that no other hazard in nature produces. That gap is what made it so difficult to understand, and that gap is why even I, surrounded by these elements for years, did not fully grasp what they were doing until the evidence became impossible to dismiss. The story begins in late 1895, when Wilhelm Röntgen discovered that a cathode ray tube could produce invisible rays capable of passing through flesh to photograph the bones beneath. He called them X-rays, and within weeks hospitals across Europe were using them to locate bullets and fractures inside the living body. Only months later, Henri Becquerel in Paris made a quieter, and I would argue, more fundamental discovery. He had been studying phosphorescent materials, substances that glow after absorbing light, and he found that uranium salts could expose a photographic plate even in total darkness, even when the plate was wrapped in thick black paper. The uranium was producing rays of its own accord, and no external energy source was required whatsoever. Here was a substance that radiated continuously from within by some process nobody could explain. When I learned of Becquerel's observation, I recognized immediately that this was not a curiosity, but a question about the deepest nature of matter. And I needed to know whether uranium was unique or whether this phenomenon hid inside other elements as well. That question became my doctoral research at the Sorbonne, and I attacked it through relentless measurement. Pierre and his brother Jacques had developed a piezoelectric electrometer capable of detecting electrical currents as small as 100 billionth of an ampere, and I used that instrument to measure the ionizing power of uranium's rays before systematically testing every element and mineral compound I could obtain. One by one, methodically, and that is when I discovered something that should have been impossible. The mineral pitchblende, the crude ore from which uranium is extracted, produced stronger ionization than pure uranium itself. The raw ore was more active than the refined element it contained, and only one explanation could account for that result. Pitchblende harbored another substance, something unknown to chemistry, something far more intensely radioactive than uranium. I followed that thread, and it unraveled into two new elements. The first named polonium for the country of my birth, and the second named radium. What followed is where the story of radiation and the living body begins in earnest. Isolating radium in measurable quantities required Pierre and me to process enormous volumes of pitchblende residues, tons of material handled by hand in a converted shed that had previously served as a dissecting room at the School of Physics. The work resembled mining labor more than anything the word laboratory might suggest to you. I stood over fuming vats, stirred with iron rods nearly as tall as I was, carried heavy containers of boiling liquid, and performed fractional crystallization over and over and over, each cycle concentrating the radium by the smallest fraction. Rain leaked through the glass roof. The ventilation was inadequate, and no fume extraction existed. Through all of it, we were bathed in radiation of an intensity no human beings had ever experienced. Pierre provided the first direct evidence by running an experiment on himself. He placed a preparation of radium against the skin of his forearm and left it there, not out of recklessness, but out of method, because he wanted to document precisely what followed. Within hours, the skin reddened as if burned, and over the following days a wound opened that required more than 2 months to heal, leaving a permanent gray scar depressed into his flesh. Becquerel experienced something similar when he carried a small glass tube of radium in his waistcoat pocket, and it burned through the fabric into his chest. He told Pierre, with a mixture of admiration and exasperation, that he loved radium, but he had a grievance against it. No chemical had touched their skin in either case. The radium acted from inside sealed glass, across layers of fabric, and destroyed living tissue without ever making direct contact, which meant that whatever these rays were, they obeyed none of the rules governing ordinary chemistry. And here is what most people miss entirely. We did not retreat from that finding because we recognized something in it. If radium could destroy healthy tissue from a distance, then it could be directed against diseased tissue with the same precision. Within months, physicians were embedding tiny glass tubes of radium directly into cancerous tumors, allowing the rays to destroy malignant growth from within while limiting exposure to the surrounding flesh. Radium was turned against tumors, against lupus vulgaris, against abnormal growths that had resisted every other treatment, and the same rays that scarred Pierre's arm were shrinking masses in hospital patients across Europe. The destructive and the therapeutic were not two different phenomena, but the same phenomenon, and the only difference was direction, duration, and dose. That realization, that a force of destruction could become an instrument of healing, stood among the most important insights our work ever produced. What we measured next shook the foundations of physics. A calorimeter revealed that a single gram of radium released enough heat every hour to melt its own weight in ice, and it did this continuously, hour after hour, day after day, with no apparent fuel and no visible change in the substance itself. Pierre measured this repeatedly, and the results were beyond dispute. Radium was producing energy on a scale that no chemical reaction could possibly explain, because the energy locked inside the atom was millions of times greater than anything chemistry had revealed in its entire history. This was the first experimental glimpse. Arriving before the theory of relativity gave it a formula of the staggering energy stored within matter itself. The burns, the wounds, and the destroyed tissue were not caused by some exotic chemical interaction, but by the release of atomic energy. The atom, which science had treated as inert, permanent and indivisible for more than 2,000 years, turned out to be active, transforming, and releasing energy of a magnitude that was almost beyond comprehension. I learned to distinguish the different emanations in our laboratory by what they could and could not penetrate. Some were stopped by the glass walls of our containers, and those were the alpha rays, heavy and intensely ionizing, but short in range. Others passed through the glass as if it were not there, penetrated thin sheets of metal, and could be deflected by a magnetic field, and those were the beta rays, lighter and faster. And then there were rays that passed through the glass, through the walls of the shed, and through nearly everything we placed in their path, and those were the gamma rays, which behaved not as particles at all, but as electromagnetic waves of extraordinary energy. It was the gamma rays that concerned me most, because against them there was almost no practical shield of reasonable thickness. Each type interacts with matter through the same mechanism, by stripping electrons from atoms and ionizing them. And when that ionization occurs within the structures of a living cell, it breaks apart the molecular machinery that keeps the cell alive. Proteins lose their shape, the delicate architecture is disrupted, and most critically the chromosomes, the very substance determining how a cell divides and what it becomes, suffer damage that the cell cannot always repair. A single atom of radium, undergoing its natural transformation, emits a particle that flies outward at enormous speed, and that particle collides with atoms along its path, knocking electrons loose and leaving a trail of ionization like a line of wreckage through a field. If that trail crosses through a living cell, the cell is wounded. If the wound strikes something, the cell can rebuild. Recovery follows. If the wound strikes something essential and irreplaceable, the cell dies, or, worse, it is altered in a way that makes it reproduce without restraint. Multiply that process by millions of atoms and millions of emissions sustained day after day, and you begin to understand what it meant to work in a space saturated with radioactive material. But here is the thing that unsettled me most. The body does not feel any of it happening. There is no pain at the moment of exposure, no sensation whatsoever. An alpha particle that tears through a cell does not announce itself, and a gamma ray that severs a molecular bond inside your body is completely imperceptible. Every other danger the human body faces arrives with a warning, because heat warns through pain, poison warns through nausea, and a wound warns through the shock of being cut. Radiation gives you nothing, no signal and no alarm, only the silent, patient accumulation of injury that reveals itself much later. I experienced that silence over years. The tips of my fingers became cracked, hardened, and perpetually sore. I carried small containers of radioactive preparations in the pockets of my laboratory coat, and the fabric near those pockets deteriorated faster than the rest. A deep, chronic exhaustion settled into my bones in a way that rest could not repair. Pierre suffered terrible pains in his legs and back that no physician could diagnose, and we attributed the symptoms to overwork, which was partly true. But they were also the visible consequences of continuous irradiation, the accumulated insult of years spent within arm's reach of the most radioactive substances on Earth. My laboratory notebooks from those years remain radioactive to this day, stored in lead-lined boxes at the Bibliothèque Nationale de France, and anyone who wishes to consult them must sign a document acknowledging the risk. More than a century after I touched those pages, they still carry the signature of what surrounded me. We were among the most knowledgeable people alive regarding these phenomena, having discovered and characterized the elements, having measured their emissions with greater precision than anyone. And yet we did not fully appreciate what prolonged exposure was doing to our bodies. Not from foolishness, but because the biology of radiation damage was a science that did not yet exist, a science that our own physical discoveries had made necessary, but that nobody had yet built. We lived in the gap between the physics of radiation and the biology of its effects, knowing precisely what the atoms were doing while remaining ignorant of what the cells were doing in response. I have observed this pattern throughout the history of discovery, where the tool arrives in your hands before you understand its full reach, and the knowledge of what you have found runs ahead of the knowledge of what it will do. What the alchemists sought for centuries through fire and incantation, the transmutation of one element into another, nature accomplishes silently and continuously in the interior of every radioactive atom. Uranium becomes thorium, thorium becomes radium, radium becomes radon, and on through a chain of transformations until the atom arrives at last at stable lead. With each step releasing energy, and each step emitting different rays. The philosopher's stone was never needed, only time and the atom's own instability. What damages the living body is the atom becoming something new, which means the injury is caused by transformation itself. The recognition that came from Stockholm confirmed what we already knew, that radioactivity was not a curiosity but a new and fundamental property of matter. But awards do not protect you from what you study. Every safety protocol used in radiation science today, the lead shielding, the distance requirements, the monitoring badges, the strict limits on handling time, all of it grew from the injuries of those earliest years. Pierre's scarred forearm, Becquerel's burned chest, and my cracked and aching hands wrote those rules in the language of the body. That is the cost of being first. Because you pay in your own flesh for the knowledge that will shield everyone who follows. Radiation teaches something if you are willing to hear it. And it is not simply that nature is dangerous, though it is, or that knowledge demands a price, though it does. It teaches you that the universe is incomparably more energetic, more restless, and more alive at its smallest scales than anything on the surface would suggest. Beneath the apparent solidity of every object you touch, every stone, every wall, every bone in your hand, there are atoms. And some of those atoms are in a state of transformation so powerful it can pass through walls, reshape flesh, and light up the darkness with a glow that no flame could produce. That is not something to flee from, but something to stand before with your instruments calibrated, your mind open, and your willingness to learn intact, because the universe does not reveal its deepest nature to those who keep a safe distance.